Okay guys, this is the second video on 4.7, Simplification of a Force and Couple System. In the first video I just tried my best to give you what I believe is the essence of, or the conceptual essence of this section, which is that if we have a force, right, acting at a certain spot on the body, and we want to know what is the effect of that force at any other point on the body, then what we do is we replace that. We take that force, we consider another point, and we place that force there. But then we also need to consider the rotational effect of that force about that point, which gives us a couple moment. Okay? And you can look at the previous video and of course read your textbook to see that. So the essence is that if we want to know what is happening at any other point, then we can replace, at that point we have that force plus a couple. Okay? And the force stays the same, but the couple moment obviously changes the further away from the line of action of that force you move. Okay? So that's why it says a simplification of a force and couple system. Now this is just one single force, but what happens if I have a body like that, and I've got a force, say, and I've got some couples, right? So F1, I don't know what to call it, minus F2, and I've got some couples, right, guys? Remember what is a couple? And I've got some forces. So if we want to, guys, we want to simplify this system, right? We've got couples, we've got forces. We want to simplify this to a single force plus couple moment. That's what we want to do. And simplifying it is based on this principle which I discussed in the previous video. Okay? So say now we have a force and we've got a couple. We want to simplify it and see that the effect essentially that it's having at a specific point O. Right? Based on what we've seen before, what we can do is, the first thing is, if we ignore the couple, we take this force, we put it at the point of our interest, and we need to also then determine the rotational effect that that force has about that point. Okay? So you're going to have F1 there, and then what is the rotational effect of F1 about that point? Let's call it M1 is equal to F1 times this D1. Okay? So now, the effect that has, remember what we're trying to do is we're trying to simplify a system that has forces and couples in it to a single force and couple moment system. Alright? So I take that force and I place it there, but then I also need to include the rotational effect. Okay? So I've got F1 plus M1. But now what about this couple? Well, remember that a couple causes pure rotation. Okay? It is a free vector. Okay, so remember, again, I'm just emphasizing this. This force, at any point on the body, not along the line of action of the force, it's going to have a translational and rotational effect. Okay, I hope that's clear. But what about, sorry, that should be a couple there. There's an L there. What about the couple? The couple only has a pure rotational effect. Remember that? Meaning, if you look at those two forces, they cancel out any translational movement. The force down is cancelled out by the force up. So the translational effect of a couple is 0, but it only has a rotational effect. Okay? So if we have that body again, then what we have here, if we're looking at point O, is we have, from this force, we have F1, and from that force we have the effect of a rotation, which is our M1, okay, which we calculated there. But now we've got also a couple moment, which is pure rotation. It's got no translational effect, so I don't add any forces here, but I do need to add a couple moment here. So we also add a couple moment due to those force. So about that point, and why can I just add it there? Because it's a free vector. A free vector I can apply at any point on the body. So based on this, how do we simplify a force and couple system? How do I do it? I have to first find my resultant force Fr, which is the sum of all the forces. Okay? And I place it at the point that I'm interested in. But then, regarding my resultant moment about point O, it is equal to two components. The first is sum of the moments about O, that this MO refers to this, the sum of MO refers to this F1 times D, okay? So this first component are the moments caused by all the forces acting on the body. But then the second moment is all the couple moments acting on the body, which is this one, okay? So that's the basic idea here. We end up with an equivalent system, right? We sum up all the forces, we place it at the point of our interest, but then regarding the rotational effect, we need to determine all the moments caused by all that force about that point, plus all the existing couple moments acting on the body. Okay? So take this, what I've discussed here, and also read in the textbook and compare notes and try to get the idea. Thanks, guys.